Morning, everybody. Let's talk about sexual dimorphism in Stegosaurus. So the species I'm going to be referring to in this talk is Stegosaurus mjosi. It was originally described as Hesperosaurus mjosi. Now this debate is ongoing, but regardless, it's the easiest North American stegosaur to identify, as it's the only one with a non-bifurcated neural spine on the vertebrae at the base of the tail. So sexual dimorphism in non-avian dinosaurs, previous attempts have been pretty inconclusive, and the crux of the matter is that there is no test for sexual dimorphism that can give you a positive result. Instead, what I suggest, and what a lot of other people have suggested, is that you first have to quantitatively identify morphological variation with an acceptable sample size, and then you rule out alternate hypotheses. So you rule out non-sex related individual variation by finding a lack of intermediates. You rule out interspecific variation by looking for coexistence of the two morphs without evidence of niche partitioning. And then you can rule out ontogenetic variation by examining the histology of bones. Once you do those things, then you can start to explain this biologically. Do you have combat structures? Do you have display structures, etc.? So why Stegosaurus? Well, the function of Stegosaurus plates has been a debate in paleontology for over 100 years, but more importantly for our purposes, the species recognition hypothesis as an alternative to sexual selection for dinosaur ornamentation was first proposed using a lack of dimorphism in Stegosaurus plates as evidence. So this is pretty appropriate. So sexual dimorphism in Stegosaurus, do we have this? So if you look at a sample of 40 plates of the species mjosi, what you find is that some are wide, some are tall. So there are at least 11 individuals based on the localities that I examined, but the plates could come from as many as 18 individuals. Took various measurements of the plates after identifying their outline. I identified their outline by looking for breakage on the plates. So you can look at the side, and if you see the internal cancellous layer, that's a sign that it's broken. Also, since the plates thin from the base to the apex and from the center outward, if a plate is unusually thick at a particular location, that's also an indication that it's broken. And what I did was I categorized them as either highly complete or moderately complete. So here you have neck plates in the sample. You got rectangular versus rounder or taller. You have back plates that are either oval or these triangular or tall plates. You have tail plates, same thing, either oval or triangular and tall. So we have morphological variation. For Stegosaurus, we have to add another alternate hypothesis, and that is that variation in plates is a result of variation from head to tail along a single individual. So you have to keep that in mind as well. All right, so what about non-sex related individual variation? Well, if you throw all the data into principal component analysis, it doesn't really tell you much. That's because this one outlier masks the variation in the rest of the sample. Orange or tall plates, black or wide plates. This outlier I would not call an intermediate. As you can see, it is triangular in shape with a well-defined apex. It comes from an isolated specimen with 11 fairly complete plates, all of which are tall. And it does not match the morphology of the wide morph at a comparable body position. So here's a wide morph plate, also from the anterior part of the back, and it's from an isolated specimen with 5 or 6 fairly complete wide plates. So if you throw out that outlier, what you find is that the second principal component analysis, or the second principal component axis, is strongly dominated by the angle between the base and the apex of the plate. This decreases from head to tail on the back of a Stegosaurus, and both the wide and the tall morphs show similar variation in this angle value, so it didn't really tell you much. But if you look at 1 and 3, what you end up getting are basically a size and shape axes. And as you can see, they roughly occur in different morphospaces, but more importantly, they diverge at larger plate sizes, and you do not see clear intermediates right here. This pattern holds up even if you look at only the most highly complete plates. You can see the divergence. So I would be comfortable ruling out non-sex related individual variation. I don't think there's intermediates in the plate, but I can say more of that at the end. Okay, so what about variation along the back of a single individual Stegosaurus? Well, the dimorphism occurs along the entire plate series, head to tail. You saw earlier that you can divide the samples into head, back, and tail plates, but you can also look at it quantitatively. So here are data from articulated species of Stegosaurus that are fairly complete, almost entirely complete, of a different species, however. But what you see is, as I said before, the angle value of the plate decreases from head to tail. And if you look at mjosi, what you find is that both morphs show a range of angle values reminiscent of these complete articulated specimens. And even the maximum size of the plate peaks at roughly the same angle value, 70. So I think this is quantitative evidence that we have a complete plate series for both morphs, head to tail. Not only that, but isolated specimens have only one morphoplate or the other. Here's a wide morph with neck, back, and tail plates. Green are highly complete. Blue are moderately complete. As you can see, I did not analyze replica plates from other species as well as superfluous reconstructions on original bone. Those were ignored. Here's another wide morph with neck and tail plates. Red are reconstructions of plates from fragmentary material. Similarly, did not analyze that. Here's another wide morph specimen with a back and a tail plate. And importantly, here is our isolated tall morph specimen with neck, back, and tail plates. So variation does not occur along the, well, variation regarding to the two morphs does not occur from head to tail on the back of a single individual because the dimorphism occurs from head to tail in both the wide and the tall plates. Okay, what about interspecific variation? So there's a quarry in central Montana that has the jumbled remains of at least 5 individual stegosaurs based on the number of pelves. These are found in a single stratigraphic horizon in a mudstone, and the only macroscopic fossils found at this site are stegosaurs. You find some concretions and gypsum roses, but you don't find other fossils. The bones vary in association, the degree of association throughout the quarry. The long axes of the bones do not appear to orient in any particular common direction. And you also find fairly small and fragile bones. So we have unguals at the, the toe bones. We have 2 articulated skulls. And finally, the bones don't show any sort of bite marks, wear, or polishing on them. So in this quarry, we have 2 types of backplates. We have 4 wide and 5 tall. But all of the bones of the skeleton come in one variety. And they come in a variety that is diagnosable as this Stegosaurus mjosi. So what do we have here? We have simultaneous burial of multiple individuals at the same location, and they were not brought together through water or scavenger transport. We have a low energy depositional environment. So what I say is, okay, we have both morphs coexisting, and there's no sign of niche partitioning in my mind because the ornamentation is the only thing that varies. In my paper, I suggest that this is a social group, but this is more speculative, obviously. Don't have to take my word for it. Other stegosaur researchers have identified unofficially these Montana specimens as being of the species mjosi. And they have officially diagnosed that isolated specimen with tall plates that we saw earlier, nicknamed Lily, in peer-reviewed journals. They also identified it as being of this species mjosi. So I don't think we have interspecific variation explaining the wide and the tall plates because we have coexistence of the 2 morphs without evidence of niche partitioning. Finally, on to genetic variation. There's actually been a handful of papers looking at Stegosaurus histology, and more importantly, they've included specimens of this species. And most importantly, Hayashi et al. 2012 looked at the ontogenetic histology of Stegosaurus plates and spikes. And what he basically came up with is this guide, where you can determine roughly the ontogenetic stage based on the structural and histological features of the plates. Now, before my work, basically the situation we were at was we had fully grown old adults and sexually mature young adults that were still growing. But what we lacked was a fully grown old adult with tall plates. So what did I do? I looked at the Montana specimens, and I followed the same methodology that Hayashi and others did. So that involved thin sectioning and CT scans. In the Montana quarry, both the wide and the tall plates have extensive external vasculature. They have extensive internal vascular piping as you can see here, which was previously identified as indicative of sexual maturity. And they also have these histological features of decreased or ceased growth and increased remodeling, as described by Hayashi and others. But most importantly, the tall plates seem to have more extensive external and internal vascularity, and they have more complete sets of these histological markers of maturity than do the wide plates in this sample. And two of these tall plates have a structure that was identified by Hayashi as an external fundamental system. And this would be indicative of ceased growth, and the tallest, or the largest tall plate in the sample has this particular feature. So here you see a tall plate with extensive secondary remodeling. Here you see a wide plate with these internal piping, vascular piping. And I also looked at the femur and tibia histology as well as the spikes. And those also suggest the presence of both young and old adults in the chorea respectively. So the limb bone histology is matching what I'm seeing in the plates. So here's my work filled in with the previous researchers. You have these two plates, which I'm pretty comfortable saying are old adults based on the work of Hayashi. But more generally, the Montana tall plates cluster around these old adult ontogenetic statuses, while the wide plates seem to have more features of these young adults. And I say that this difference within this quarry is further evidence that one individual does not have both wide and tall plates on its back. Okay, so we ruled out ontogenetic variation by looking at histology and finding that both the wide and the tall plates come from fully grown animals, and that the plates themselves are fully grown. So I think the most likely explanation is sexual dimorphism. What about explaining this biologically and assigning sexes? That's where it gets a little harder. So unfortunately, no medullary bone has been found in Stegosaurus. I didn't find it in my samples either. And that would allow us to definitively assign one specimen, or one morph, ideally, as female. So we have to hypothesize instead. Modern bovids, the horns in the males are sexually selected, while the horns in the females are naturally selected as predator deterrents. So I'm thinking about that when I'm looking at my Stegosaurus. The one caveat is that the plates are display structures. They're not combat structures. You don't see dimorphism in these tail spikes. So instead of a male-male competition system, I see a female mate choice system. Now, an energetics hypothesis says that, typically speaking, males invest more into growing and maintaining their ornaments than females. The wide plates reach surface areas, maximum surface areas, 45% greater than do the tall plates. So I say, okay, here we have a male with a continuous, broad display surface, and here we have a female that, just like these bovids, has this predator deterrence kind of prickly appearance to it, for lack of a better word, I guess. So I want to go back to what I said about looking for intermediates and testing against the idea of non-sex related individual variation. I have unpublished work with the French morphometrician Vincent Bonham, and I probably mispronounced his name, I apologize. But he has developed a package in R which allows you to statistically test for differences in outline shape. So what I did is we ran these, the tall and the wide morphs in his package, and we found significant differences in the shape between the two morphs. This significance holds up even when the most highly complete plates are the only ones that are used. And more importantly, unlike my principal component analysis, you don't have to rule out an outlier. So it's a much more rigorous approach to looking at it. The final thing I wanted to note, and on a similar vein, is what other people have been calling for in terms of trying to identify sexual dimorphism in I guess, extinct animals in general. So there have been recent claims that bimodality, we need to look for bimodality in a particular trait to see, here's one peak is the female, one peak is the male. The problem is that it's too high of a standard, and it would only detect the most extreme dimorphisms. We know that many modern examples of sexual dimorphisms do not appear to be bimodal. In fact, probably the most common one that we're all used to, human height, is not bimodal. If you just look at a whole group of men and women together, it's not bimodal. And basically that's a artifact of if you combine two normal distributions, if their means are too close together, when you sum them together, you're not going to get a statistically significant bimodal distribution. So what I say is, if we accept this as our standard for identifying sexual dimorphism in dinosaurs or extinct animals in general, we're going to miss many, many, many examples of sexual dimorphism. It also ignores, including the complications from if you have juveniles in your sample, or for Stegosaurus in particular, the neck plates, which are less dimorphic. Remember that dimorphism increases with the larger plates. So there's a whole bunch of caveats to this, and I think the general approach is it's too high of a standard. That was what I wanted to end it on. There's tons of people in Montana, Princeton University, Bristol, elsewhere that I could thank. I guess I'll thank the Alumni Foundation because they funded my trip here specifically. So thank you, everybody.